Please open in your learning workbook to page 113 as we solve two problems involving rationalizing a radical expression where there is only one term in the denominator. All right, let's begin with this problem. 6 over the cube root of 25x squared. The first step is to write the prime factorization of the radicand. In other words, rewrite 25x squared using a factor tree. 25x squared is the same thing as 25 times x squared. 25 is 5 times 5, and x squared is x times x. So this is a 5 times a 5 times an x times an x. Now you might have noticed that I left a little space here and here. I did that on purpose, and here's the reason why. Our goal with rationalizing a denominator is to get rid of the radical. But we can only get rid of the radical if we have perfect groups. This is a cube root. We don't need 2 5s, we need 3. We don't need 2 x's, we need 3. So the way we're going to achieve that is we are going to multiply the top and the bottom by what's missing. We need another 5 and another x in a cube root. So we're going to put the cube root of 5x here and here. Okay, so now we can multiply the fractions. This is going to give us 6 times the cube root of 5x. And when we multiply these together, we can combine the two radicals with the product rule for radicals because the index is the same. So this will be the cube root of 5 times 5 times 5 times x times x times x. Now we can simplify this radical by making groups. We need groups of 3. Well, there's a group of 3, and there's a group of 3. We have perfect groups because we created the problem to have perfect groups. So the numerator stays the same, 6 times the cube root of 5x. But in the denominator, each group sends one representative out to multiply. So we get a 5 and an x, and then no more radical. So our final answer is 6 times the cube root of 5x over 5x. Notice that the denominator no longer contains a radical. The denominator has been rationalized. That is the goal of this problem. Eliminate the radical in the denominator. Okay, let's try another problem. The problem we just completed had a cube root, so now we're going to try a problem that has a square root. 1 over the square root of 45z. And since our variable has changed from x to z, we're going to change the instructions so that they say assume that z is greater than 0. All right, we're going to solve this using the exact same method. So we need the prime factorization of 45z. Well, 45z is made up of a 45 times a z. 45 is 9 times 5. 9 is 3 times 3. So we've got a 3, a 5, and a z. Okay, and once again, you might notice that I've left some spaces here. I did that on purpose. All right, so this is a square root. To simplify a square root and get rid of the radical symbol completely, we need to have perfect groups of 2 because the index is 2 for a square root, which means we need another 5 and we need another z. So we're going to multiply by a new fraction where the numerator and the denominator match, and they are both the square root of 5z. Same kind of root, and it contains the things that we were missing. Okay, so now we'll multiply our fractions together. In the numerator, we have 1 times the square root of 5z. Well, anything times 1 is itself, so we have the square root of 5z. In the denominator, we have 2 square roots, so those are going to combine to make just one radical. So we'll have a 3 times a 3 times a 5 times a 5 times a z times a z. And because it's a square root, we need to make perfect groups of 2. So here's a group of 2, here's a group of 2, here's a group of 2. Each group sends one representative out to multiply. So what comes out is a 3, a 5, and a z, no radical anymore. Now put it all together. Our final answer is the square root of 5z over 15z. Okay, this is the method that we use to rationalize denominators that contain only one term. It is very, very important that you remember that. When there is one term, you use the prime factorization of the radicand, multiplication by something that completes the radical, and simplification.